In this lecture, we're going to talk about the Spring Framework. So I said coming into this course that we don't need to know the Spring Framework to get started with Spring Boot. And while that's true, I think this is a good opportunity just to get a little bit of a background on what the Spring Framework is and what it contains. So the Spring Framework was created by Rod Johnson in 2002. The framework was created to enhance developer productivity and enforce some of the industry's best-known coding practices. Spring Framework is free and open source and is now maintained by Pivotal. Central to the Spring Framework is the inversion of control, or IOC container, which provides consistent means of configuring and managing Java objects. The container is responsible for managing object life cycles of specific objects, creating these objects, calling their initialization methods, and configuring these objects by wiring them together. Over the years, the Spring Framework has become so much more than just an IOC container, though. The Spring Framework includes several modules that provide a range of services such as dependency injection, AOP or aspect-oriented programming, data access, security and authorization, web in the form of an MVC framework, REST services, and so much more. What we're looking at here is the Spring Framework runtime and all of the different parts and pieces of it. And we're just going to kind of run through them and give just a basic description of what they do. So the Spring Core container is the base module of Spring and provides Spring containers such as the Bean Factory and application context. Aspect-oriented programming, or AOP, enables implementing cross-cutting concerns. Authentication and authorization is configurable security processes that support a range of standards, protocols, tools, and practices via the Spring Security Project. Convention over configuration is basically a rapid application development solution for Spring-based enterprise apps. Data access allows us to work with relational databases and even non-relational databases on the Java platform. We can use a wide range of tools such as JDBC and ORM to access those databases. Inversion of control we kind of touched on already. Messaging is basically configuring registration of message listener objects for transparent message consumption from message queues via JMS, and improvement of messaging sending over standard JMS APIs. Model View Controller is basically an HTTP and servlet-based framework providing hooks and extension and customization for web applications and RESTful web services. And we'll talk a little bit about testing later on, but testing basically gives us support classes for writing unit tests and integration tests. So you can see there that we have kind of the different parts and pieces that make up the Spring Framework. And it starts with the core and then kind of adds on some different parts to create this entire runtime. Next, we're going to talk about the Spring.io platform. We just looked at what the Spring Framework is made up of, but what are the different projects under the Spring umbrella? We're going to cover some of these throughout the course, but if you want to find more details about them, head over to spring.io/projects. So it used to be that you would, if you needed, a capability X, you had to pull in these dependencies, and if you needed capability Y, you had to pull in some extra dependencies. Spring's, more importantly, Pivotal's done a much better job of kind of combining everything into sensible projects. So we're just going to talk through a couple of these projects here. So Spring XD, it basically simplifies the development of big data applications by addressing ingestion, analytics, batch jobs, and data export. Spring Boot, which obviously we're going to talk about a lot in this course because it's about Spring Boot, but Spring Boot takes an opinionated view of building Spring application and gets you up and running as quickly as possible. Spring Cloud provides a set of tools for common patterns in distributed systems, useful for building and deploying microservices. Spring Integration supports the well-known enterprise integration patterns via lightweight messaging and declarative adapters. Spring Batch simplifies and optimizes the work processing of high-volume batch operations. Spring Data, which we're going to look at in this course, provides a consistent approach to data access, relational, non-relational, MapReduce, and beyond. And finally, Spring Security, which we're also going to look at in detail in this course, provides your application with comprehensive and extensible authentication and authorization support. So we didn't cover every little thing here, but we covered a few of them. But like I said, head over to spring.io/projects to learn more about each individual project. And there's some great documentation on all of them. So why the Spring Framework? As we said before, the Spring Framework enhances developer productivity. It's free and it's open source, so why wouldn't you want to use it? We looked at all of the modules that the Spring Framework is built on, and there's a lot of stuff there, so we get a lot of capabilities out of the box. Spring developers are in demand. If you look at job sites and job postings, everyone's looking for Spring developers. If you know the Spring Framework, you're not going to have a hard time finding a position. And really, who wants to go back to EJB and enterprise development? No thanks. Just a little bit more about Spring, just so you can stay connected, and these will be in the resources, but just a couple resources for you here. There's a Twitter account for Spring Central. YouTube has some great videos at spring.io/video. You can ask some questions about Spring at that link. And if you find an issue with Spring, you can always raise a Jira issue at jira.spring.io.